This is Jack Jackson. In this video we'll be talking about angles in real-world context. Oftentimes when we're measuring angles in a real-world context, we'll impose some sort of coordinate system with the vertex of the angle at the origin of our system. Now, in many applications we have different ways of doing this. So for example, if we want a way of measuring a standard angle in mathematics, we can give it by what's called a vector is giving a magnitude and a direction. Okay, and so we can list a distance here in an angle. So if I change this distance, right now it's 6 units out, suppose we go out 3 units. And let's say for right now, let's go out 90 degrees. We know, you can see that on the scale, that is 3 units, and that angle is 90 degrees. And remember, we measure math angles from standard position, from being terminal or initial side being on the positive x-axis, vertex at the origin. We rotate positive in the counterclockwise way and negative in the clockwise direction. So for example, if we go negative 45 degrees, it's going to rotate down there. If we change the length to say 5 units, it's going to be longer. So that's how we measure angles in mathematics. But in many real-world examples, we'll set this on a grid where we have north, south, east, and west. The origin will be some interesting point that we want to put it on the graph, on the map. The positive part of the x-axis goes east, the negative is west. For the y-axis it goes north and south, with upwards being positive or north, down will be south or negative. Now, in real-world positions, there's a couple of different ways we can do this. One is called heading. And heading is always measured from north, and it's always measured in a clockwise way. And so it's always an angle between 0 degrees and 360 degrees. So right now we're seeing an angle measuring 275 degrees. So we're measuring the angle as if we start with the initial side on the going north, and then rotating around. And of course we can put a distance to it. Right now this is 8 units long. We could make it shorter, maybe 6 units long. That didn't change the angle. If we can change the angle as well, so we could have an angle of 35 degrees, then we're pointing northeast there. If we put the angle say bigger than 90 but less than 180, like at 200 degrees, I'm sorry, let's go a little bit less than that. Let's go 150 degrees, less than 180 but bigger than 90 degrees. Now we're southeast. Of course, straight down south would be 180 degrees, would be pointing due south, and then a little bit bigger, 220. Now we're southwest. We want to go directly to the west, 270, I believe, yeah. And then like 290 would be in here, and so forth. If it's pointing directly north, we say it's 0 degrees. So that's heading. Heading is always measured from north, going in a clockwise way. So the angle is between 0 and 360 degrees. 0 and 360. Distance, we can however also do it by bearing and distance. The distance is the same. And so I've got 4 different directions here for our vector, and this orange one here, as you see me moving, is pointing northeast. Northeast. Notice we don't say east-north, we say northeast. And so that's kind of how you measure it. You start facing north and you rotate east or west. In this case we're rotating to the east. And so this blue angle is kind of what we're measuring. Notice that angle will always be an acute angle, but it's measured from the vertical. Okay, so this one's about 45 degrees. So north, 45.277 degrees east. And the distance is 5.14. So I can change the distance here along that by moving this part here. So right now we're at a distance about 4.8, and we have that. You can go north 82.7 degrees east, like that. If we're down here in the fourth quadrant for our terminal side here, our with our vector, that's going to be southeast. And so, we think of going south and rotating to the east. How far to the east do we rotate? Well, looks like right now we're rotating about 27 degrees. So south 27 degrees, or 26.82866 degrees east. So notice how that's written, south so many degrees east. And then this is the distance, which would be some distance unit like miles or feet or meters or something like that. Down here in this quadrant, we're southwest. So we look either north or south, which is closer, whichever is closer, and we rotate to the east or west. So, for example, that would be south 73.4 degrees west. Up here, where the green one is northwest. So again, you point north and rotate to the west. This green angle here is how far we rotate to the west, which in this case is 49.3 degrees. So we can locate a point here by giving a distance and bearing. We first of all could get the bearing, so north so many degrees to the east, north 72 degrees east, and then we could go out a certain distance here, maybe somewhere in here, that would be basically 12 units out here. So notice those are three completely different ways of measuring angles. The standard mathematics way of doing it, which is measured from the positive part of the x-axis. The bearing and distance, which is measured from north or south with an acute angle. And a heading and distance, where you're given the distance and then you're measuring the heading from north. So different ways of measuring that angle in a real world context. So when we place this in real world problems, you might have something given as a heading, you might have something given as a bearing. So you have to understand what those terms mean and how to use that in the context of that real world problem.